This is part 3 of the hazardous environments. This is looking at 3 major case studies to match with what we've learned previously on tectonic hazards. The case studies for tropical storms is in part 1. Okay, so if you like this, guys, I really want to make more resources, but like, comment, subscribe, share, do all that stuff. Look below on the link as well and just see if there's any additional resources for you in your Edexcel IGCSE course. If you are not a part of that course, that's okay. This will still be really useful if you're studying volcanoes and earthquakes in any curricula. Okay, we're going to start off with Nepal and we're going to look at an earthquake. So for an earthquake, we already looked at the idea of seismic waves. Here we're at a collision plate boundary, and yeah, Nepal then is centered there in the Himalayas, sandwiched between China and India. I'm going to give you a lot of information about these case studies. It's good to really know them as you're going through, plus it's also really important when you're studying geography to apply your knowledge properly. So it happened in 2015 on the 25th of April. It was a magnitude 7.8, which on the Richter scale, that's a very high magnitude, with aftershocks coming in up to 7.3. So those type of aftershocks, 6.6 to 7.3, would be considered major earthquakes in their own right. So a lot of construction then was damaged, and the aftershock came in and did quite a lot there. The epicenter was 77 kilometers to Kathmandu, which is considered quite short. So this means that the seismic waves moved out from the epicenter and reached the capital city with a high population density. Now, in this curricula, you also have to look at developed and developing countries. So in this one here, we're talking about a kind of developing or emerging country in Nepal. So we look at its GDP, or gross domestic product per capita, and it just shows that people roughly make an average of 3,800 a year, but potentially less. So that's indicating to us that they have it's a low income country. Infant mortality rate of 25 is very high, and a life expectancy of 72 is quite low. So this is showing us that their healthcare center, their social care, and all these things are actually quite low in the country as well. And their major industries, tourism, agriculture, manufacturing, is showing us that they're also a developing country, especially with a high reliance on things like agriculture still. Now the effects on people and the environment then over the short term, we see that there was 600,000 homes destroyed and almost another 300 homes were damaged. And this was in the 14 worst hit districts, especially in Kathmandu. So when you're looking at those areas that are damaged and still feeling aftershocks, this means it's almost 1 million homes that people cannot live in anymore, and they've been forced to leave because a lot of people wouldn't go back in with the aftershocks and the danger of the building collapsing later. We can see the total death toll then rose to about 8,800, injured over 22,000. A lot of people were trapped in buildings or in rural areas where they had no help there, or people couldn't get to them in time. We see this left 1.7 million children left homeless, and in upper areas then in the Himalaya mountains, there was avalanches on Mount Everest. In Langtang Valley, for example, there was a huge landslides that completely removed villages from the valley. Earthquakes then, we saw over almost 3,000 landslides and huge cracks opening up in areas as well. Areas like the water sources were contaminated, chemicals were washed into the source as well, and this created major problems. There was also like glacier lake outburst floods. We can see that Nepal, because the epicenter was there, was the most damaged. Other countries then had lower population densities close by, and the seismic waves that traveled were still causing damages and injuries to people and still causing deaths, but Nepal felt it the most and got the brunt of the impacts there. For long-term damages then, they had to reconstruct huge amounts, up to 9 billion, and in a less developed country, this is a lot of money. So imagine that sometimes things are a bit cheaper to actually rebuild there. In the mountainous areas, it took a long time to get any aid or support, days, weeks, months to rebuild anything and get things like roads and access ways back open. Helicopters were used a lot where possible. A lot of people were homeless. Tourism revenue, which they're heavily dependent on, was then cut because there was multiple seasons where tourism declined and people weren't willing to go there because they were rebuilding after a natural disaster. We see the glacier lake outburst floods mentioned in part 2, so they happened as well, and now there was risk of further landslides and damages due to that, and that needed to become a part of their protection program as well. A lot of forest was taken away because of all the landslides as well. So this takes a long area to regrow, and those forests really have a job to do. Basically, they are going to cause more slope stability, and they're going to reduce the amount of water and flooding in the area too. So them being taken away takes a long time to grow back and restabilize the area. Contaminated groundwater takes a very long time, many years for it to resurface. So they'll still be dealing with that in the future, meaning that they'll have to rely on infrastructure with tap water and treated water as well. So how do you reduce the impacts for this? Prediction, there was a prediction that a high percentage chance that there was going to be quite a large earthquake in the coming years. However, when you're predicting earthquakes, we can't really say that it's going to happen for sure. We just know that tension needs to be released at one stage. Seismographs, GPSs then will show motion and will talk about the tensions being built up. But as the country then is limited in its income and the amount of money it has to spend on defenses, there's a limited amount they can do to prepare for that. The response then, the short-term response was seen as rescue teams within the country moving into action and helping people, especially with initial rescue from building sites. So Nepal sent a huge amount of first aid, and they had lots of different organizations trying to work together, and communities as well coming together. Their neighbor then, India, came in with a huge effort from the Air Force, lots of tents, blankets. Nepal was happy to receive a lot of items, but didn't want their professional personnel to come in due to a lot of political problems. Ireland and South Korea, for example, sent about 1 million in USD just in aid, just for them to afford to cause the emergency services to come in, or food, blankets, these types of things. Canada sent their response team, their team, 30 person, so that is highly trained professionals to help and get people out of rubble or to give them assistance in rural areas. And then we see Chinese sending over a rescue team as well, and lots of additional money and supplies by both of those areas. Bangladesh, a neighboring country, a less developed country, and they even supplied lots of food and bottled water. So we can see here the big international effort to help out less developed countries, especially one with Nepal, who has such close historical ties with so many nations around the world who have traveled there and go mountaineering there. And then there's just regular humanitarian aid as well. So international, but also NGOs, non-government organizations like Red Cross will have a certain amount of funding and professionals to send out to these disaster areas as well. This is often to reduce the death toll and make sure that secondary hazards like water contamination don't spread disease, and people have shelter, food and water for the initial days to weeks afterwards. This is incredibly important for a less developed country. The long-term response then, rebuilding, economic growth again, bringing back in tourism was incredibly important, and to build the infrastructure too. With prevention then moving forward, they looked at the concept of secondary hazards like landslides and glacier lake outburst floods, and how to stabilize as many of those in very strategic points. So if you reduce that or have some basic like flood protection engineering, and building things in the right way, so that you maybe expect a landslide or a flood, but you're going to reduce the impacts on the people in the rural area. And this includes kind of buildings as well. So if you can build your buildings that are less rigid, this will help them to stay upright. With isolated base structures, for example, a lot of people in Nepal would not have the money to build those types of buildings. So we will not see them at the same level and at the same amount as you would find in more developed countries. So for earthquakes, we've got to have a comparative. Our comparative here is New Zealand. So New Zealand is a less densely populated country, although kind of similar in size, also mountainous, but would be a more developed country, or HIC, high income country. There we can see it just southeast of Australia. So in the South Island in Christchurch in 2011, they had a magnitude 6.3, so considerably lower than the one in Nepal. The aftershocks were quite large, up to 5.3, but the epicenter was much closer to the urban area, which was only 10 kilometers from Christchurch, and the focus was very shallow. So we'd mentioned before that the focus being shallow means that the seismic waves are going to be more intense, because they don't have as much ground to go through. And just a little comparison then to our Nepal case study, we have a GDP per capita of 48,800. Infant mortality rate is much lower at 3.3, and the life expectancy is almost 10 years longer. So this shows us that there is a big development gap between both New Zealand and Nepal. The short-term effects on people and the environment, then we see 185 deaths and thousands injured. We also see the collapse of a lot of buildings, including the Canterbury television studios as well. Infrastructural damage then to places like the cathedral, major landmarks, but also they had a really bad destruction of infrastructure like sewerage, gas pipelines ruptured, railway links destroyed, and bridges as well. So this meant that it was very hard then to move people around and get the help to where it's needed. It also increased the cost dramatically then in the long term too. But short term impacts, that means less help can get there, less people can get away from the disaster zone as well. The economic impact on it was huge because all businesses were shut down, many people lost their jobs, and this was a really massive economic hit for the area, and a total of 40 billion then in New Zealand dollars. So about 10,000 homes were damaged enough that people needed to be removed either temporarily or permanently to wait for rebuilds or to move to other areas that might need a rent. Now the long term, we look at the economic repercussions, then long term rebuilding, but also the main thing was the insurance payout, and the government tried to boost this as well to give a payout in this area because there was so much that happened at once, and in the area a lot of places would have been insured, which meant that people were going to wait until the insurance money came out. So improvements didn't really happen very quickly at all in the area, so it was a very slow rebuild in many places. A lot of tourism then declined and didn't rebuild because a lot of people could avoid it and stay elsewhere, areas that hadn't been hit so bad by this earthquake or other natural disasters, which meant that you have to take a long time to get your reputation back a bit and for people to want to go there. Also, just to have a lot of free accommodation and affordable accommodation as well is less likely after a natural disaster because so many people need to use those rooms. Urban regeneration, especially in the central business district, was important, and also bringing in new infrastructure that were designed with to withstand seismic waves. So this was huge. A couple of buildings went up then that are very resistant to seismic activity, having things like base isolation systems, which we'll have a quick look at. And the psychological impact, anxiety, PTSD from the seismic event, which is very, very often in natural disasters. People might not be able to get over it, or their perception of risk might change. And due to that and other reasons like a lack of housing, slow insurance reaction to this to pay them back, meant that a lot of people left. And also entire areas then were red zoned. So this means that the government knows that they're at higher risk from seismic activity, so they don't want people to rebuild over it to have the same problem again. So this red zoning then meant that a lot of people were pushed out of the area, changed their community, and they might not want to live in Christchurch at all and potentially move to another part of New Zealand with less stress, psychological impact, and financial burden. So they looked to change quite a lot, but before the earthquake, New Zealand wasn't really as heavily impacted as Nepal because they already had things in place. So they had seismic building codes, and then they also knew that these wouldn't stand a very high seismic wave or high magnitude of an earthquake. But they had some codes. Like if we look here, the building behind this one that's been torn down is more high rise and it's still standing afterwards. Also as well, they just had established the civil defense system, meaning that they have quick response teams into the areas that they're trained, they know what to do, they have a contact, they have a goal when the natural disaster happens, and then they can move in and do this as professionals and help to organize other groups of volunteers. The monitoring then, the GNS science then is going to monitor different seismic activity, and this will kind of give them an example of what they maybe would expect moving forward, and to be able to anticipate that there would be earthquakes of certain sizes coming. That way they should have got really well trained and well prepared, and also put the building and infrastructures in place. However, the buildings weren't totally in the place, so that had to be changed slightly there. So the response then, short term, was the emergency responses again. Lots of international aid came to them immediately, especially neighbouring countries like Australia with close ties to them. And we see then all the emergency services from around the country coming in to help out as well. Now, with all the infrastructure that was destroyed, air ambulances were very, very important to bring people who needed treatment away from the disaster zone into nearby urban areas and other major cities like Wellington. Those changes then end up costing or end up saving quite a lot of lives and are incredibly important in the initial hours. So lots of people were evacuated from the areas. This is to reduce from secondary hazards like contamination of water and waterborne diseases breaking out too. Schools, stadiums are often used then and converted into temporary shelters because they've got the space and a lot of people have access to it. You can then help all of those people in one place rather than trying to get around to them all over the city. So concentrating your supplies and professionals into one area reduces down the risk. Because of the low population density, this is much more easily to pull off rather than places with incredibly high population density like Kathmandu. It would be very hard to organize all these things in one space to help everybody out. Now, when we look at the other things that were done, like road clearing, military coming in, that's very common as well during natural hazards. A lot of military personnel then well trained, they can mobilize and work together as a big unit then to make some big changes and potentially help people out short term and long term. Emergency broadcasting means that people can get information and they can do something about it as well, which is incredibly important. And on top of that, we get financial and logistic support coming in from multiple countries in order to pump into the system as much money as possible so that they can do as much with that in the short term to reduce the loss of life and give people as much protection, housing, water, food as possible. Long-term recovery then, a lot of buildings had to be torn down and then rebuilt. There was this huge insurance support, the government support as well for rebuilding. The Earthquake Commission then looking at the residential buildings, making sure that they are going to be a little bit more seismic resistant in the future. And also this red zoning we mentioned before was very important to reduce the risk moving forward and just to make it a bit more sustainable. This idea of liquefaction we mentioned in part 2, where a lot of the soil then can be a high percentage of liquid, causes the building to move and change. So they wanted to create more things like drainage to allow for less, or to not allow for this to happen in the future. Mental health and community support then was quite important. The PTSD then over the long term, incredibly important there. Their prevention then is looking at really just the buildings, having the buildings based. The base isolation system means that the building doesn't shake uncontrollably from the base, but just moves with the seismic waves rather than against them. So this reduces the chance of them collapsing. It's quite expensive technology to use, but it is very, very efficient. So having these definitely retrofitted then buildings that were still standing, they could be retrofitted with new technology, meaning that you could keep the building structure, reduces the overall cost, and then it was able to make places like schools much more protected. With the education and drills, then it's important that everybody knows how to react. When you have the seismic waves coming in, you can react to them then differently, but some reactions can cause a lot of lives to be saved. And then looking at the urban resilience plan, then just making sure that infrastructure is in place, like the drainage that we mentioned before and bridges, that they supply the right amount of support for seismic activity. Alright, so those are the 2 earthquake case studies, and we'll quickly have a look at our volcano. We go over to the Atlantic Ocean, over to a constructive plate boundary where we see volcanic eruptions happening on Iceland. Iceland is a developed country, so again, nice to compare to the other countries. A higher GDP than the others, has a lower birth rate and a life expectancy of 83, which shows you that it's quite well developed. Tourism, aluminium and fishing being big industries in the region. So again, it's not a very big country, and it's even more sparsely populated than New Zealand and much more than when we were looking in Nepal. The Eyjafjallajökull eruption then in 2010 came off on April 15th, and as mentioned there, the North American and Eurasian plate are moving away. So this is happening in a constructive plate boundary along the Mid-Atlantic Ridge. Now the big thing about the eruption here, there was a glacier, and underneath this eruption happened. So as the ash was trying to move out, it turned the ash into big particles, and these particles were so large that they were really disruptive, and a lot of planes then couldn't take off all around Europe. So it had this huge disruptive nature there. Locally then it caused a lot of meltwater. There were some kind of lahars in the local region and a lot of respiratory problems because of the ash cloud and the density of it in the area. This enormous ash cloud then started to cover Europe. So when we're looking at the impacts and what makes this case study quite interesting, is we really are just looking at such a vast area when we're talking about the whole of Europe being impacted. Now, one thing to add to this, which is quite interesting, is that this natural hazard didn't actually, well, until COVID, this probably did the most disruption we've ever seen over airspace and tourism around the world. So it was still talked about up until 2020, and then a lot of other things impacted tourism. By the way, guys, so as I said before, if you want like sample answers and to see how to use this case study detail, go down and check out the links below. There could be a course ready to go there or something else that might help you, depending on when you're looking at this. Also, you know, like, subscribe and all of that, please. Yeah. So we have short-term effects then on people. Short-term effects, we look at evacuations in Iceland, evacuations of the local area, because again, volcanoes can be monitored, checked. There's lots of signs that things are going to happen. Loss of livestock, because it might be easy to move people, but moving huge amounts of livestock is not as simple to herd them together and to get the right transport. About 20 farms were destroyed then due to ash cloud and meltwater as well. They cause floodings like lahars. And yeah, we see this from the Iceland Meteorological Office and National Emergency Agency. So they come into play because they send all the warnings around and they dictate who should go where at what times to remove them from danger as fast as possible. So it's good to have this system in place, especially in a population with a low density. But also, you know, it has a lot of tourists who might not know all the methods of reducing the risks as well. So you've got to educate them on it as well. Iceland, the short-term effects then were that about 95,000 flights were delayed. This created this huge surge of what we called volcanic refugees at the time, where they were stranded in areas that they had flown to, and after the eruption started, they would have to either find different methods of transport or wait till the skies were clear again. So imagine 35,000 people, a couple of hundred people in every single flight. So that's how many people were waiting then to fly out in other flights. So disrupted air traffic for a long period of time. And this is where we saw one of the biggest kind of like financial drops in travel agencies during that time. It also changed the way that we deal with insurance now as well with travel and transport. On the environment, we see that the glacier melted, so that's quite a rapid melt. That meltwater is supposed to be slow and stable, and therefore keeping the drainage basin cycle and the water cycle at balance in the region. So this imbalances that, which again can destroy habitats. So lots of floods destroying farms and habitats, natural habitats. Outside of Iceland, we saw lots of organic waste because of a lack of transportation, right? So air transportation is used for goods. So a loss of that seems like a bit of a waste. The volcano itself released about 150,000 tons of CO2 per day, which is a course of greenhouse gas covered in a different section of the course. But what was interesting is that by grounding 95,000 planes, we actually stopped millions of tons of CO2 from going into the atmosphere. So it was kind of actually an environmental balance, and maybe an environmental positive actually when we look at it and think about it. The long-term effects then, we look at Iceland. Yeah, we see that there was ash that settled on the glacier. So after the initial melting because of the eruption, there was also a long-term melting as the glacier, when it's darker and covered in ash, is going to pick up more heat and is going to cause it to melt faster. Respiratory problems then happen for inhalation of particles of ash to animals and people. Outside of Iceland then, we see that like trade had been very much changed, and we saw that loss as well. So it took a long time to recover from that in the tourism industry, and insurance and trade losses were in the billions. Other countries like Kenya, for example, a lot of cancelled trades involving food would have had a knock-on reaction of like say cash crops that they're trying to send to more developed countries. This interruption then would have stopped the supply chain and would have impacted their income for a long period of time. So it's kind of hard, you know, to deal with all of these short-term, long-term income impacts. All volcanic eruptions are going to be different on different scales. This one, the scale was huge, but we didn't see a huge loss of life because of that, even though the scale was very large. With the prediction, we already looked at prediction methods in the last section, but absolutely, weeks before this, we were seeing that the volcano was swollen, so we see deformation. There's also seismic monitoring that went with that as well to see any seismic events or little earthquakes that were happening as the area was changing. But deformation is an indication to quite a large eruption about to happen. So looking at secondary impacts and anticipating where they went. So gas released, water then impacted, and a physical change in the structure, all giving us a prediction that this was going to happen and for evacuations to be ready. So the prevention then, we mentioned the meteorological agencies, they warn and they evacuate. That's one of the best ways of dealing with volcanoes, because some of the eruptions then are so large that it's hard to build something like a physical engineering project that would change the course of an eruption. Then we see, everyone alerted and ready to go. So this means their supplies are ready, they may evacuate early, and they can find their way to temporary shelters. But the other thing about Iceland is that even though so many people were evacuated, they didn't need that much infrastructure. So only about 200 people needed refuge off the entire island. And because of their low population density and the fact that many of them just stayed with friends or relatives during this period. So it wasn't as stressful because high levels of development, high levels of organization and prediction compared to the earthquakes that we had a look at. But also, they lived close to family and friends. So rescue teams ready to go, short-term, long-term responses ready to go. International agencies still come and help, but are not as much needed, especially when we don't have a huge humanitarian crisis afterwards. And it's interesting, so even though they lost quite a lot, Iceland then found that more people afterwards started traveling there and were interested in the concept of going to see a volcano. On the other side, in areas around Europe, we saw that things like trains and ferries and taxis then suddenly increased. So different industries picked up maybe the loss of the economic value of the air travel companies. And then wherever anyone was stranded, they might have had to stay for multiple days, so they were spending money even if new tourists couldn't come into the region. So those are some of the impacts that we look at with the volcano and some of the sort of ways in which they deal with that. So with that single case study of a volcano, 2 of the earthquake, that should keep you covered and is also the end of our Hazardous Environments Unit 3.